Whew, let's get the ball rolling. It's been a while. Let's take it easy today. It's raining hard outside. There's lots of water. Just get a little cozy. Figure out my code for the day, you know? Let me fix my webcam as well. A little bit. It's not exactly perfect, but all right, here we are. Okay, name of the game is casual and calm today because I've been a little on edge with my programming. Been a little uneasy, unfocused. So I'm hoping to kind of capture a few things into their proper libraries and clean things up a little bit. I feel like that'll be a good use of my time. Although, let me check something for a second. I'll be right back. All right. Let's get some work done here. All right, let's see what we got. So actually, what I kind of want to do first here is think a little bit about. So I've got these two things here. Cypress, I actually kind of think I don't need to do anything to it right now. I think, let's have a look at the git status of this here. How do I check? Let's see here. What's the command again? Is it just diff? Git diff file name. Yeah, okay, that's what I thought. Geez, it's bright compared to the rest of my room. Which, actually, now that I say that, let me let me adjust this. Yeah, you know what? That's okay. Let's do that. Let's stick with that, huh? A. Git diff file name. That's all I want to do. Let's do git diff source. Oops. Source. SVG CLJ parametric. Oh, right. So we're getting into, oh, now I'm starting to remember. I want to, require some stricter things on for parametric curves and surfaces. And I want to make sure they're equivalent between Forge and the SVG library. That's kind of where my brain is, that's kind of where my head's at. Yeah, I think that makes sense to do that. So we'll focus on those things a little bit here. Okay. Apologize for the slow start, you know, just got a lot going on in real life, you know. Nothing bad, just been out of focus a little bit. There's a few things I could work on actually. If I'm just kind of casually getting into the swing of things again, maybe I shouldn't like be so hard on myself here. I'm just streaming, just having a good time. Just trying to get my code in order, so you know, nothing too crazy about that really. Yeah, so okay. Let's do a little bit of writing in. Okay, let's make the call to close that file. So we've got a little bit of clean living going on here. Okay, so I want to look at first the SVG library, then Forge we'll have a quick look at, well, we'll have a good look at next. Okay. Let's make a little note in parametric here. The parametric namespace has functions that generate useful geometric parametric elements. Primarily, they fall into one of two categories. Point list generators. Example, regular polygon points. And the second type of thing is well, how do I say it? Parametric functions, higher order parametric functions, taking in args and returning function of t, function uv, like that. The point lists are not technically parametric, though they are quite useful. They are quite useful in conjunction with the parametric functions, especially considering the polygon and polyline parametric functions, which take in lists of points. Right, okay, so fine. Curve calculations. All right, let's have a look at this here. Okay, so let's see what we've got here for arc length, because that is pretty important actually. I wonder if there's, let's see here. Well, that's not at all what I want to see here. I'll worry about that later. Okay, so what I've got here. Well, let's not worry too much about that for the time being. Let's add a little thing here called design. Yeah, so the parametric functions return a function expecting a parameter in the curve case, or a set of parameters in the surface case. Note that surfaces are not really used in the SVG CLJ library. Okay. A parameter denoted as T by convention. Right, so given a parametric function, you can pass in a parameter T whose with a value anywhere between 0 and 1. The function is then expected to return a position in to return a position in it can be an n-dimensional position, but in SVG CLJ it is almost always 2D point x, y. In my library, I'm using a zero-arity call to any parametric function to return a map of details about that curve. This means that every parametric function that constructs one of these parametric functions must properly generate this map for oh boy, it's kind of hard to articulate really what I'm trying to get at here. Right, so the required keys for the curve map are, let's see. Right, so we've got function, we've got input, length, which is either estimated or whatever. How do I want to do this? Let me sorry, I'm really all over the place today. I'm a little bleh. You know? Does anyone know what I mean when I say that? I don't know what I mean. I don't know what I'm talking about. Did I do this wrong? All right, let's just do this. Okay, here we go. So we're just gonna type a map in as an example. So, right, so we've got function. It's gonna be function symbol like that. Input arg1, arg2, like that. Length is arc length length of curve estimated, exact if possible, estimated otherwise. Sure, that's fine. Then here I do for sure want to have so in the case of a line, I haven't put it in here. I'm not so convinced that fast line is a good idea. Oh, I do also need to handle remap within a little. No, remap within should be fine. Vertex params. I think that's fair. Yeah. It's also, well, let's not worry about that yet. Is fastline used anywhere? It's not, so I think I'm gonna get rid of it. Excuse me. Okay, well, let's save things. Probably should vertex params. I was in the middle of saying I should probably have a validator function that makes sure the zero arity call of a curve exists, and that calling 0 and calling 1 are guaranteed to emit values. I think those are good requirements. The required keys for the curve map are here. Right, so vertex params is t values at which input vertices at which t values where the curve equals the input vertices. Right. Let's see. So for sure, function and input are useful because you can rebuild the function call from that data directly. You can arguably save out the parametric curve after all kinds of transformation to an Eden file and then just reconstruct it in the running environment later if you just want to load it and then like reconstitute the function or something like that. So there's some kind of potential useful way to save files or something. I don't know. That's maybe getting ahead of myself a little bit. Additionally, it is required that any parametric function that modifies a function transforms also matches this zero-arity scheme. This is because certain algorithms will be built requiring data from these keys. In particular, length is valuable to have basically calculated at basically pre-calculated when the curve is first created. I don't know if that is fair to say, but instead of constantly calculating and updating length, you can just look it up in a map is the idea I'm trying to get at here. So you never, like if you're given a curve and you want to use the length a bunch of times, it's been calculated and the data exists in the curve as a function already. So you don't need to recalculate it. That's the whole idea. You just pull it with the length key. Right, so that I think makes sense. I think that's pretty good. Finally, it must be true that f0 and f1 are valid points, not nil. Okay. So given that, I should probably put a little curve function validator or whatever. So curve parametric validators, parametric validator, yeah, something like that. What do I say? Something like check curve. No. Check parametric function. Man, I don't know. I'll just write something and kind of fix it up as I go. That's always how I do it. Usually works out fairly well. Okay. Oh, let's go ahead and there we go. Let's do it like this. Yeah, that works for me. Let's go like this. All right, here we are. All right, so check parametric. That's what I'm interested in figuring out. Oh, let's also load. Oh, that's not gonna work yet. Check parametric. There we go. Save. Load file. Source SVG CLJ. Parametric. Good. Okay, so check P circle 20. Oops. Right, it's just going to return empty, which makes perfect sense. Def A circle 20. If you do A with a zero arity call, right, it has function, input, and length, which here we go. We technically haven't fixed anything at all. It's incomplete because it's invalid. So let's use that as a good testing. Okay, so let's do let keys pred let's see, Clojure see, check if map contains all keys. Right, you do every Oh, I forget about every all the time. Let's use that snippet though. Keys pred F data is just F. Right, so every contains F data, and then keys is what I need. Needs to just be a list of required keys, which will be function input, oops. Okay, that should be good, I think. So that's the keys pred. Oh, let's do T0 pred, like that. This is maybe a weak way to do it, but start with that. That's fine. T1 pred, not nil. Wait, is not nil a function already? No symbol. Okay, that's fine. Doesn't matter. Wait. Sum? Sum A0. True. Okay, let's just do sum instead. I think that's valid. No, let's do start with that anyway. It's fine. Okay, so let's do let's make it return a map, right? So dimension is take a 0.5 call, count. Right, so curve dimension is given. Valid T0 pred, valid T1 pred, dimension, data is f data. Yeah, that seems fine. I don't know, let's try it. So if I do this, check parametric of A. Okay, dimension is 2, that makes sense. The data is given there, which is great. Valid data, false. I wonder if I could get a like an explainer, like why. Valid data false, keys pred, like it's missing some key. I mean, let's do something like missing when not keys pred. Okay, when keys pred is false, that means it's missing some key in the data. So missing will exist so well, let's finish that. Okay, so missing is when not keys pred. All I want to do is let's do required is just going to be this. Oops. Okay, so when not keys pred, I want to do keys of f data. That's not what I want to see. That's okay. Spam emails. Okay. When not keys pred, right? You do excuse me, remove set keys f data. Remove those from set required. Is that gonna work? I think that'll work. Missing. Okay, let's see what happens. Missing vertex params. That's pretty cool. Right, okay, except that what I really want, okay, I have no idea if this is gonna work the way I think it is. No, let's not do it like that. Let's do this. Okay, let's do results, result map is this thing. Okay, so let's do that, and then here we do when missing exists. No. Let's thread result through when missing. Oop. Oh wait a minute. Cond thread, how does that work? I think that's right. So cond thread, let's double check this. Clojure cond thread. What? Thread last. How do I search for this freaking function? That's annoying. It's not even a function. It's okay. Clojure cond thread macro. There we go. Cond thread. There we go. Okay, this is what we need. Okay, so cond expression clause. That's all it is, right? cond, start the thing when the condition, yeah, okay, good. When the condition is that, wait, is it thread first, cond thread first? Presumably there's also a cond thread last, right? Yeah. What's this? Ooh, that's gonna be useful sometimes, for sure. That's quite useful. But that's not what I was getting at. For now, I am going to do cond thread. So cond thread when missing, then you do assoc into result missing. Otherwise you don't. I think that'll do what I want it to. Huh, it did not do what I thought it would. Huh. And why not, I wonder. Okay, so there's something going right. Okay. Why is this cond thread not working? I don't get it. Let's try that. Okay, missing does go in there properly. Cond thread, please. What am I doing wrong here? Oops, true. Yeah, okay. Oh, wait. Can I just do this? Is that gonna work? Oops. Huh. Well, okay. Let's now define one. Let's fix line, first of all. So, vertex params is easy in this case. It's going to just be 0 and 1. Okay. So let's def b line 0, 0, 1, 2. Right, so let's... There we go. Perfect. Valid, true. Love it. I realize I want to change this up a little bit here, so let's change f data. T0 is f at 0. T1 is f at 1. So here, sum T0. This should actually be a bit different. Let's take T0, T05, f at 0.5. And then we'll get the dimension from that. So we'll get dim count T05. There we go. So data, dimension is dim. There. And we want let's see. First of all, well, okay, let's see. Every number. Let's see if this actually is going to do what I want it to. I don't know if this is going to do what I want, but let's find out. 0, 2, true. Ah, perfect. That is exactly what I want. Okay. Well, and let me just double check this. That's true. And then this is A, false. Good. Okay, so we want and we want T0 to actually be a value, and every number T0. Okay? And I think that's valid. I think that makes sense. Oh, we would also actually want well, let's do count and equals count T0 is equal to dim, right? And just groups these checks together, really. Okay, let's see if that makes sense. Okay, let's see. Perfect. Okay. So that's actually good. So what I can do is use this pattern. I can use this pattern to kind of build out a helpful map of results, I think. So let's do well, how do I want to handle that? Missing makes sense. When not T0, Okay, I think that makes sense. Wait a minute, let's change how we do this. Let's just do this. There. Okay. Let's wait a second. When not, yes, okay. I think that makes sense. Let's check parametric. A, error, we get the missing error. B should have no errors. Good. So then we could have a little right, valid parametric. Ooh. Oh. Do this. False. True. Okay, good. Those are helpful, I think. I think those are useful. Then we can go ahead and use that to kind of fix up a few of these things. Right? I think that makes good sense. Let's put a little note to myself here. A utility for checking validity of a parametric function based on the design requirements, in particular of the zero arity function. There are also some checks for validity at f0 and f1, since the end conditions can sometimes get confusing and break down. One assumption made is that f at 0.5 will be valid in terms of the dimensionality of the curve. Thus, well, anyway, for now, this is perhaps a sufficient assumption for checks. This check does not determine yet if the implied function from function input will be equivalent. This may be a feature to build into a full check parametric or something later on. For now, I'm not worrying about that. Okay. Bathroom break, I'll be right back. Okay. Woo, my neck. Let's see. Oh, you know what? We should have another thing here. Oops, that's not what I meant to do. Okay. If I run something, like if I do valid parametric on a function that takes a value t but returns just t, I get this error, wrong number of args. So try the expression catch clause is nil. Finally, nil? No. There we go. That's kind of the form I want. I think I don't remember if that's valid in Clojure script, so I have to kind of check that because I need it to be. All right, let's see. I don't think that'll work, but let's try it anyway. Hey, C Films. Glad you're doing okay. I'm doing well. Been getting back into the streaming. It's been, I think, a week since I've done it, so always takes a little bit to kind of warm up, but feeling good otherwise. How does when let work again, or if let? Let's see. How have things been going with you, C Films? I hope they've been going well for you. How was the interview? The interviews went well. I have yet to hear back. Like, I expect to hear back sometime this week. I think they went quite well. I'm feeling hopeful, but trying not to get too excited, you know. But I do think I did quite well, and I enjoyed talking with the people I interviewed with. I enjoyed doing some coding coding exercises, and yeah, overall went quite well. Thanks for asking. I appreciate that. It's really nice. All right, let's see if let. Is when let a thing? Let's try to figure out how to do if let properly, because I to be honest, don't know how to do it. I don't think I've ever used it before. If let, oops, that's not what I meant to do. The interview coding was in what language? I was doing it in Clojure, so felt pretty comfortable in that language. Felt pretty good about that. Yeah, they let me use my language of choice. I know that they use Clojure on their backend stuff, so I half expected that they'd be problems that they would know how to do in Clojure quite well. But I was allowed to use whatever language. I chose Clojure because it's the one I'm for sure the most comfortable in. So, yeah, it was good. All right. I have no idea if this works. Oop. It does not. Are you into math? I mean, yeah. I'm not exactly sure what you mean by that. That's kind of a big question. Generally speaking, yeah, I really enjoy math and math topics. I'm not like the best, but I'd say on average I am for sure. Like, in particular, as you might guess, I'm really into geometry-based math, so do you think 3 plus 5 equals 8 or 8? Well, that's not math strictly speaking. That's floating points, right? It equals 8.0. That's kind of asking about type coercion, right? A little bit. Like, it's kind of... what's the right way to say it? Should, if you know two floats are exactly equivalent to their non-float integers, so if 3.0 is exactly the same as 3 and 5.0 is exactly the same as 5, then should their result also be exactly the same as their integer equivalent? I don't know. Are there languages that will coerce back a number automatically from a float or double into its own normal integer value? I don't know. If I do 8.0 minus 8, it's a 0 but a float 0, right? So you could like do... I don't know. So like from a pure math perspective, this 3.0, 5.0, 8.0 is equal to 8 exactly. It'll be false in a programming sense, but in a mathematical sense they should be equal, right? But that's not like, realistically we have to store imprecise values with a finite amount of memory, so it's for the sake of programming, not equal. And if I were designing a programming language, I would probably do this, where it doesn't assume anything and just outputs a float value. If you're using a float or double, whatever you want to call it, somewhere in your computation, it could result in a float or double in the output, and I think that makes sense to keep it that way. Alright, let's see. What am I in the middle of doing here? Oh, you know what? I'd rather not do this complicated thing this way. I think I'm not doing it right anyway. So let's try this and get back to this. As a starting point. A programming language can distinguish between float and integers. Yeah, I know. I'm not sure what you're getting at. Like, is there, can I launch a Python? No execute function for Python. Huh. I don't know what's the deal with that, but that's okay. You mean in McFly? So yeah, how are you handling it in McFly? If a user passes in computation with a float value inside the computation somewhere, how are you handling that inside your program? Sorry, 1 second. This is an important message. Any number with a decimal point is considered to be a float. That is how you're handling that? But I mean, like, if you're adding 2.0 plus 2, are you making it return 4.0 or 4? What just happened here? I am not particularly focused today. Oops. If I do now... Oh, this is wrong. This has to be F. Like that. What? Why is that wrong? Oh, it isn't wrong. I see. Two point oh plus 4 currently returns 6.0. Yeah, which is that like the behavior you want? Because that is, oh, I'm adding the wrong numbers, but the point stands. That is, I think, how basically every programming language does that. That makes sense. Okay. Right. Check parametric of C. Trying to think about... Oh, well, First off, let's def C is a function of T returning like that. There we go. It's not valid because, yeah, okay, that actually works. Right, association error, not missing, but invalid, 0 arity. Right, that should nil. That's confusing. Do you use pi or tau more? Pi, but it does depend on the context. If I'm using a lot of rotations with radians and stuff like that, I might do something like, I might like at the top of my file do def tau times 2 math pi, like that. And I might do def pi even is just math / pi to keep it shorter. But it's just, since it is just 2 times pi, it's very trivial to just let the user add that, so I don't like have it explicitly included anywhere, you know? I just define it as needed. But I usually kind of just leave it at pi. Anyway. Oh, I guess that that's why something was going wrong. Right. Let's go try. Let's have a look at a try here. There's something about catch that I need to do. Can I do catch default? Oh no, it's Clojure script only. That's a little bit annoying. Right, let's see. Let's try that. It won't work, I don't think. Yeah. Let's do did I do that right? Seems like I did. I should, let's see. I realize there's probably a better function for this. In lots of programming languages, 0.1 plus 0.2 equals 0.3 is considered false. Point 1, 0.2. This is probably false, yeah. And that makes sense, right? Because floating point is not like this, is the true result of 0.1 plus 0.2 in floating point arithmetic. This is the correct result. If I were to do a equality check with this value here, it would be true because that's exact, right? It's just that it breaks our intuition as humans reading it, right? So it's totally sensible for a program to say that that's false. And this is exactly why equality checks for floating points is not really a great idea. Instead, what's often a good thing to do is something like instituting an epsilon value. Let's imagine some small value, and then instead you do something like if. So instead of equality, you do if less than if the result of subtracting, right, the checks you're gonna do, let's do, I don't know, defin floating equals, right? This is not a perfect implementation, but let me just see. Right, so you got your epsilon value, defin f equals, you taking a and b, for example. Let's just do a double comparison here. If less than if a minus b, if math abs of a minus b is less than eps. Oh, actually, I don't even need the if. Just do that. Then you can do f equals. I think I did this right, maybe not. Oh, I didn't do it right. There we go. Right, so what you're doing is you're making a comparison for less than epsilon as opposed to exact equality, right? And then you can adjust epsilon to be whatever makes sense in the context, because if you're checking really small values around 0, you might want an epsilon value of a certain size. But if you're checking for equality, approximate equality, around really high numbers, excuse me, around really big floating numbers, then you want your epsilon to be quite different. So it can get pretty complicated. But it's almost always a bad idea to check exact equality with floating point values, is kind of the moral of the story. I also realize f nil is no, never mind. This is correct. this is wrong. If this is not, I don't know if I like this idea. I mean, we'll try it anyway. Okay, so this should prevent, let's make this private, by the way. I don't want that really to be, okay, here we go. Let's do check parametric C, right. Dimension of C is 2, right. Let's do check parametric of function, taking in T, returning T, still not correct. Should be not dimension like that. That I don't think that'll fix it, but all right. So man. This is not clean. This is pretty, let's just do it like this. I don't love this, but it's the only thing I can think of for now that'll be kind of okay. All right, so if sequable F0, if it is, then you just do F0. If it's not, then you do F0 like this. You know what? Let's do this. F0, F05, F1 is map F over 0, 0.5, 1, like this. Then we've got those. And then we can do this dirty business here. If F0 is sequable, then it's F0. Otherwise, it's F1 or F0 wrapped like that. Likewise for 05 and uh, 1. F05, 1, 1, 1. There we go. That should hopefully prevent. Okay, there we go. So now the check parametric works on different types of function inputs. It doesn't give me hard errors, which is, I guess that's helpful for right now. I don't want it to fail so much as just give the user, if they're constructing parametric functions, the ability to kind of check things out in the REPL as things are going. There's probably better designs, but for now this is pretty good. So if I do valid parametric, it should be false, and that is exactly what I want to see. Okay, but if I do valid parametric of A, that's also false, even though it returns some valid stuff. What I can do is, if that's not valid, I can actually run check parametric on it for me, and it'll tell me inside the error key what's wrong, and it's missing vertex parameters. Okay, that means my function circle is not working correctly. So, or it's not fully, it's not completely well defined. So instead of leaving it alone, I want to fix it up, which is easy enough. Okay, so we've got vertex params is just going to be a list. 0 and 1 should be exactly identical. So I guess I should put... Ooh, this actually raises an interesting question about what are important vertices to include here. I kinda... I kind of want to do this at each quadrant, but I don't know that that's sensible. I mean, there's no harm in putting it in there for now and getting rid of it later, right? The nice thing about the length as well is you get an exact calculation. It's 2 pi times the radius, which is guaranteed to work here. Oh, you know what I should do as well? I should have optional... wait a minute, do I want that? I mean, I guess it's not bad to have it. There's no harm, really. Okay, so let's redefine A. Let's do check parametric of a circle. Okay, everything here is now valid data. Its dimension is 2 because we're in the SVG thing that works. Called it with circle, input is 20. Vertex params exist, valid data true, valid T1, valid T0 both true. Perfect, that is fantastic. Okay, did I include? Okay, good. Invalid T's are correct. Good, good, good. Good, 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 good. Alright, on that note, I'll be right back. I won't be long. All right, let's keep on trucking. Let's just keep on slowly piecing together a bit of a story about this parametric stuff. If I'm comfortable and confident with the design going into my SVG library stuff, then I can kind of transport that same set of concepts nicely into 3D. I've been experimenting with it in the pottery org file, a lot of surface and curve stuff, which is really, I think, quite great. But I have to solidify it, make it more concrete to kind of make it more usable overall. So that's just all part of the process, honestly. Okay. I think that's going to be a task of mine, which is getting 0.1 plus 0.2 to equal 0.3. Do you have an idea for how you want to handle that? Because that sounds like it could be a complicated sort of process. Like, are you going to create a new number type or something? I don't know. How are you thinking you might want to solve that? All right, let's see here. Let's see what we can keep doing. All right, so we've got ellipse. Right, so what I don't have here, I need the vertex params. And then it should be okay, I think. Let's just run check parametric on it anyway. Let's make an ellipse, 20 by 40. Valid, length is there. Vertex params seems good. One solution is to make floating point numbers decimal numbers. Oh, is McFly written in Python? I can't remember where you're implementing all of this. Or are you doing it differently? Like, is decimal number a different number type in your language? Because yeah, I guess. Let me even see. Forget how to make. It's written with Python. So does Python have a decimal number class or type or whatever the right word is? I forget how to do it in Clojure. Decmial. Right. I've never thought about really looking into this closely, to be honest. Clojure data types. I guess I shouldn't waste too much time on that right now, just so I can keep moving on my own stuff. It's not that important right now. Okay, did I run check parametric on an ellipse. I did. Okay, let's try to run an arc here. Okay, so we need vertex params to have, it for sure needs 0, for sure needs 1. I think that's kind of it, honestly. Python has a decimal module which provides support for fast, correctly rounded decimal floating points arithmetic. Oh, well, in that case, you're quite set. You could probably use that in your interpreter just fine. What type of shape are you trying to make? I'm not really trying to make any shapes at the moment. What I'm trying to do is improve and build a few checks and balances for my parametric curve shapes in general. Because I want to build a more reliable set of transforms so that you don't end up breaking things, to be imprecise about it. Let's see here. I have radius R. I should put radius in here. I should probably also put center CP. I don't know about this. Really, I'm kind of making value judgments here where, you know what, I don't need that. So actually what I think actually this is a better thing to do for something like a closed, actually no, a closed ellipse. It kind of makes sense to have the ends and the tangent points of along the major axes. That makes sense to me. But excuse me, a circle. No, I'll leave it. That's fine. An arc for sure. It needs 0 and it needs 1. Yeah, I don't know. Okay, if I do that, that kind of works, right? Let's make a call. It's a continuous curve, so the vertex parameters that matter are, you need 1 to matter, but you don't necessarily need other ones. So I am gonna just take the other ones out. Call that good for now. Excuse me. Okay, so arc you need 0 and 1. That seems good. Okay. Bezier. Now we're getting into some complicated stuff. Slightly more complicated stuff. I realized, well, this is kind of complicated. The length of this Bezier, I need to, I don't know why I have this sentence here. That doesn't really help me at all. But let's I think once I come up with a way to approximate the arc length of a Bezier curve and get that kind of working, I'm gonna call this stream done. I think that's really all I'm gonna have time for. Right, because this Bezier curve is recursive all the way through. Which actually, I realize that might end up being a problem. Okay, let's have a look at, let's def A is Bezier, the list of points. Let's just do 0, 0, 10, 20, 40, 90, 120, 230, sure. Right, so if I do check parametric A, missing length and vertex parameters, of course, that's fine, but the data that gets plopped in there, dimension 2 is fine, Bezier with the input is fine. Okay, so my idea is this. You build out this whole structure without the arity at all, the null arity or zero arity thing. Like this. Then here, well, first of all, let me see that n Bezier is it like works as a function. Let's map a range 0 to 1, 0.1. Seems to produce points. Let's do this. Are they the same? They should be. 3, 8, 15. Yeah, okay, they're the same. Good. But if I def A with n Bezier, A zero arity doesn't work. But then what I'm gonna do is just create this function to be let f be, well, let the curve C be n Bezier points. Okay. So then here, length can be arc length of curve. That should work. And now here, we can build out function zero argument. How did I make this look here? Boy, oh boy, I'm getting a little tired, to be honest. Like that. Okay, perfect. So the function we called was Bezier. The input was points, totally perfect. This vertex params I'll sort out. Not implemented. Length is going to be implemented as length there. So that's good. Okay, right. Then function with one argument t is very simple. It's actually just curve t. Okay, let's try that. So let's def a as Bezier. Ah, yes, slow because of the arc length calculation. So maybe I want to think of a different approach, but right, so it's valid because it has all of those, but vertex params not implemented, obviously not helpful. Do I want to calculate certain key vertex parameters? Let's start with just 0 and 1 because that's pretty obviously necessary. And I think I want to kind of leave that as is for the time being. Let's see, fast line length calculation algorithm. See, what I want is, no, I don't want, right, anyway, that'll be something for later. I think I'm fairly happy with that for the time being. Oh, I'm gonna have to check this now, aren't I? That's gonna be a whole thing. Let's pop that into its own thing, because that's a can of worms. Hey, Code Prince. Or Code Prince, sorry, Cedar Prince. Totally misread your name there for a second. Sorry about that. Also, hello. Yeah, hello to you as well, Cedar Prince. Not Code Prince. Do I know how to make a is it Voronoi or Voronoi? I don't know. Unfortunately, I don't. Not yet. That's been on the back burner for me to learn how to do it. So, Voronoi? Yeah. Wait, I forget which one I did. Anyway, yeah, unfortunately the answer is no. What I have, so I feel like the answer Voronoi. Okay, gotcha. Thank you. I feel like if I give myself a little bit of time, I won't be too far off, because what I do have is a Delaunay triangulation implementation in here. In algorithms here, Delaunay, And the thing about Veroni and they're the dual of each other. So I feel as if I'm close without having a clear answer to it yet. So let's see here. Just out of curiosity, why are you wondering about that? Do you have a particular need for that algorithm? Are you working on something related to it? The only reason I haven't done it is because I haven't yet had a personal need for it, you know? Yeah, hey, Martin. Long time no see. I hope you're well. Yeah, this is what we're talking about here. Veroni or Voronoi, whatever it is. Hey, glad you're doing well. That's good to hear. Partition of a plane into regions close to each of a given set of points. You're working on the Julia animation engine. Right, I remember you mentioning that before, and you're thinking about making a video on how to make the diagram. I mean, that sounds like a great video topic, honestly. Go for it. That sounds really quite cool. The honest and true reason why I don't have it implemented at all in my own stuff is purely because I haven't yet needed to. For anything that I've wanted. Truth be told, there might actually be a really valid reason for me to do it, and I'm sure it'll come up soon, but like at some point in the reasonable near future, but haven't had to do it yet. It's a little bit... I've been working Cedar Prints on... what's a quick way to show you this? I mean, well, so right today I've been doing the less glamorous stuff. As a first pass, you're trying to think about how to make it statically. Gotcha, yeah. I mean, that's always a great place to start, right? And then anytime I've thought about doing things for animation-wise, in my own head, I think about, okay, how can I make this static thing continuously dependent on a single value t? And if you can have a continuous version of it where you could put t to be any value from, say, 0 to 1, for example, and you get a static image out of that particular function, suddenly you can animate it, right? You could set your frame rate, and then you just vary t between the frames, and then boom, you can stitch it all back together as an animation. I did that exact thing with... Let's see if I can pull it up here. I've got, oh yeah, let's do MPV pillar 2. I did that exact thing. It's not Voronoi or Veroni. It's not Veroni. I'm in my own head about getting it wrong now. I'm gonna keep saying it wrong. It's really good thinking. I used that exact thing to make this animation, which I really quite love. This was static SVGs, and then I used FFmpeg to stitch it back together. It's not a real-time animation. That's a bit of an asterisk on it, but it's pretty cool. Quite proud of that one, to be honest. And that comes... Oh, I don't have it open. Maybe I can start it up. I have built a really rough and ready animate function that you pass in a function of t that returns a frame. Do you give the depth of field to give the impression of it being 3D, or is it actually 3D? That was actually 3D. So what I did was made a 2D blob shape, right? I transformed it onto a 3D into a 3D space. an isometric projection, like as if it were a CAD program. So it's a 2D curve placed into 3D, so it's trivially 3D, right? Because the Z value is 0 initially, and then you just rotate the camera to the isometric axis perspective, and then you get those curves positions, and then you just project it back into 2D by lopping off the Z value, and then you'll get that there. So what I did is I did that once, and then I did it again, but translated up by Z. So then you get this sort of stack of 2D things, and they all are a blend of each other, and they all blend in time. So it's like a 4-dimensional blend kind of thing. It was really cool. It was a lot of fun to work on it, to be frank about that. Yeah, I was really happy with it. All right, so let's. Ooh, no such var offset points, eh? Bummer. Well, I don't want to debug this right now because I don't have a ton of time. But I did make that animation. Here, I'll show you the function that created that anyway. Blend pillar animation here. Okay, it kind of confuses me because it's not like the cleanest possible way to do it, but I generated a whole bunch of steps along the vertical thing, and then each of those steps is continuous also in time. So you get different blends amongst each of the layers, and then it returns a function here taking t as a parameter, right? Like I said, and then so it's very slow. I didn't make it an optimal calculation, but for every t value you put in, it calculates all of the proper blends and does all of the transformation and spits out an SVG for a single frame. That's all it's doing. It's basically like tons and tons of linear interpolations. But it ends up looking really cool, so, you know, I'll take it. But I've been working lately on some 3D stuff as well, so let me actually try to show you that for a second too. So I've been using, so the reason this has all popped into my head is because, well, one, animating, two, Voronoi and Delaunay the Voronoi diagram and Delaunay triangulation being the dual of a Voronoi diagram. They're related to each other. Delaunay I was using for triangulating, but I actually implemented a different triangulation algorithm for the purpose of creating surfaces in 3D space, using and then creating a mesh. What? Oh, there we go. All right, let's load this bad boy up. See if we can get it going. Man, I keep messing things up, unfortunately. Oops, that was wrong. Where is open surface? Uh-oh, what have I done? Ah, ooh. Okay, I don't know. Maybe I fixed the order. We'll see. This is why, so it's a bit of a more mellow stream, but these are the things I'm trying to, I use other little projects and stuff to kind of experiment and build out new functionality, but what I need to do is capture it back in a controlled and thoughtful way into the actual libraries. And this is the stuff that starts to happen if I've been experimenting for a long time in the REPL. I end up messing up the order of definitions sometimes in the main source file. And that's the kind of stuff I have to start. I just have to, it's a little tedious. I just have to kind of fix it up, make sure things are working, moving functions to the right spots, and cleaning the projects up so that they're nice and less repetitive and everything. And then I end up with weird stuff like that where I accidentally just typed incorrectly there, which is a bit annoying. But we get there one step at a time, right? Seriously, now what? Ah. There we go. Boy, oh boy, that took an unfortunately long amount of time. Alright, let's see. Right, so I don't know if anyone's still here from... If Cedar Prince is still here, but this bottom face is triangulated from Clojure, not inside the 3D app. So I was using Delaunay triangulations before, but I replaced that with an ear clipping algorithm, which leaves me with worse looking meshes in terms of the triangles being poorly formed. Although I'm working on improving that. I have some ideas. Ooh, that's not what I want it to look like exactly. But here, right, the reason I do ear clipping is because it doesn't matter if the polygon being input is concave, which is very helpful. Yeah, so these are some of the things I've been working on lately. So getting a nice regular triangulation for a mesh from a continuous surface. Delaunay triangulations and Voronoi diagrams and stuff like that could be useful for artistic purposes, but I haven't actually run into the direct need for it in terms of pure geometry yet. I'm sure I'll find ways for it to show up, but I digress. Alright, I think I am going to call it a day. It's been slow for me. But slow and steady is not so bad, honestly. I'm not too bothered by it. Do appreciate a bit of chat here and there. That's really nice. Thanks everyone for that. If there are people watching on YouTube or something like that, hello. Consider following on Twitch, you know, becoming a subscriber, doing a Twitch Prime, anything like that. All those things are really helpful. They kind of keep me focused on elements that people want to actually see. They give me the encouragement to keep doing this. It's not like this it takes time. I have to focus. I have to, you know, keep paying attention, keep trying to improve my coding and all of that stuff. So it's a lot of fun to do, but it does take effort. So, you know, little bits of support are always nice. They're never required, but it's really awesome. At the very least, sending me a message saying you like my stuff is already just phenomenal. But blah, blah, blah. I'm just yammering at this point. I am going to get going. I should be back tomorrow around the same time. Thanks, everyone, for enjoying the stream. I hope you all have a good day, good evening, good sleep, and a good morning, and on a rolling and continuous basis. All right. That is going to be all from me for the day. Bye-bye, everyone.